Hey, how y'all doing?
Good. How are you doing?
Oh, hold on. Okay, if one of you would unmute and say something, I can see if my headphones are working.
Can you hear us?
Yeah, I heard nothing, so maybe. Okay, hold on. Let me check the settings because that could be a problem. Audio. Okay, so in theory, you should be able to hear me, but I'm going to switch gears to.
And that should sound a little bit better. And now, could one of you say something out loud so I could hear, perhaps?
Hello?
Yes. Okay, I heard that. That's better than before when I wasn't hearing anything. But, you know, that wasn't necessarily my fault if none of you said anything. Okay, so where we stand is this. Well, there's this test thing coming up, and if I remember correctly, it's opening today at about 5 o'clock. So in other words, you can start taking the test right away if that's something that you'd want to be doing. Some of you will want to do that, and I'm thinking that's fine. Absolutely fine, no problem. I'm going to sort of show you a couple things administratively by sharing the screen. And okay, go desktop, go, yay. And there should be questions and answers right here. Now, if you look at this exam, it looks like I've grabbed exam from a past class, and these are questions that I've asked of a Stat 313 class in the past. And so you should think not too different, perhaps, than the sorts of things I'd like to ask of you and have you answer. And I'd like you to feel comfortable with your answer. And so if looking over those questions and perhaps the answers provided already, you might want to clarify some things, which is great. You might have questions related to content that we talked about yesterday, the general linear model, and in particular parameterizations. That's a good thing to talk about, or frankly, anything, because other than that, I have nothing planned and I'm good for just sitting here for, well, another 45 minutes or so. I might lose patience by then, but hey, you got any questions on anything?
This is just kind of, is that the sample exam questions? Is that how long we should expect the actual exam to be?
Okay, great question. Let me look at that sample exam and comment on it. In terms of the amount of time I would expect a student would take on this set of questions, well, there's some matching or, you know, choose the right answer. Oh yeah, this is like, oh my gosh. Okay, so that's 1.5 tests plus a, so that's about 2.5 tests worth of questions. Students in past terms have always said, oh, well, you know, give me more questions. And so if you as a student could tackle this set of questions and all of them in approximately 130 minutes, you're working about at the right pace, maybe a little bit slower. It'd be better to get through that in an hour and 20 than an hour and 30. I mean, 130 minutes, that's 2 hours 10. I apologize. If you could do it in 2 hours, all of that, you're in good shape.
Is the data for each question going to be like readily available for us to like go through the software ourselves?
Yeah, this is an exam from when the students were not being given the data. Actually, correct. So for most of these, the students had not been provided data. You will be provided data if I want you to be given the data set, or data sets, I should say, because some questions, they could be entirely hypothetical. And if you're able to tackle those hypothetical questions, yay. If I, however, have the data available, I'll provide it to you. And you could use it if you'd like to. Not a requirement. Again, every single question should be something which you could answer without opening the data set or using GMP at all. Now, if you prefer to do that, that's fine too. Many students do use GMP and the data set provided or data sets provided a fair amount, and they do just as well or just as poorly, if you want to phrase it that way, sort of negatively, as students who are working with the data as if it's just a piece of paper and that's it. Using the data and the software can be helpful for some questions for some students, and other students could use an equation and logic out the answer to the same problems. So yes, I think to be specific. I'll provide stuff, you use it if you want, not required. Well, so far that's not so many questions. And to be honest, we're in a situation where I want to answer questions you have, but some of you may have already looked at the answers provided and said, okay. Or if you looked at the answers provided and you weren't so sure, you might have gone back and looked at some other classes videotape of me answering those same problems. And so it's not a requirement that y'all have questions now, but I was a little surprised with only one subject matter question, and not even hardly that so far, more administrative.
Could you go over how, like a general linear model data set and just how to interpret like the y-intercept and the slope?
Okay, so I would love to do that with the data set that I asked you to use for the homework. Okay, admittedly, the homework's not due until a while, right? But the parameterization homework questions, maybe talking about those in general, will both help for you with the homework. If you had questions, you might have fewer of them. But also, I like to talk about that data set because it's sort of a fun one, and it might also tie to some good learning. Shoot, now wrong place, and I found the right folder, and now I have to find A for antibiotics. Okay, so here are the antibiotics, and I'm really paying attention to these two columns. Some software packages would allow you to more easily work with the data in 1, 2, 3, 4, 5 columns. That's not JMP, but still students could look at, just for chloramphenicol, for example, means and standard deviations, no problem. And from that, you could calculate things like the sums and squares between the groups, etc. Okay. I'm just looking at binding percentages and the antibiotic overall, and I want to do 2 quick things. One is to find the average of the binding percentage without regard to which antibiotic it is. Okay. Really, that is just a way of saying what's the average. And if I stack it up there, I'm going to leave it right down in the right corner. The average binding percentage is 22.935. If I use GMP's fit y by x, no, we don't want to do that one. If I use GMP's fit model, okay, analyze fit model, you'd say that binding percentage perhaps depends on which antibiotic it is. Boom. I could click run and get a bunch of output, but I want to focus on the parts that are maybe most important. And that would be our, well, okay, so you have a p-value below 0.05. You believe that there is a difference in the average binding percentages somewhere, or you could say it this way: there is no impact. I'm sorry, there is an impact of which antibiotic it is on the binding percentage. I'm not saying all of them have an effect, but at least one of them has an effect. And those parameter estimates sort of describe those effects. Let's look at those a little bit. So you can see the intercept is the mean of all the data values. Boom. Or if you will, better yet, the average of the averages. The lab yesterday might have caused some of you to say, hold on a second, the grand mean is not necessarily the average of the averages. So we sort of need to know what those averages are. Let's go ahead and calculate them. And I'm going to use fit y by x for that guy. Antibiotic, could I look at the binding percentages separately for each of them? Yeah, I get a graph, but I don't care about the graph as much as I want to look at just the numeric values for the means and standard deviations. Okay, so let's look at our chloramphenicol. It has an average binding percentage of 27.8. If 22.935, so, let's call that 22.9. If that's the average across all of the groups, all of the binding percentages, the average of these 1, 2, 3, 4, 5 averages, how much higher is chloramphenicol with a 27.8 above our average across all the groups of 22.9? And I'm thinking if I go up from 22.9, if I go up 4.9 from it, I get the 27.8. Indeed, you can tell me from just these averages and then the average of the averages, you could figure out both the intercept, the average of the averages, plus the effects. How far away are you from the average of those averages? Let's look at a different example. Streptomycin. Streptomycin here is a 7.8. The average of the averages is 22.9. How much above or below 22.9 is 7.8? It's, I guess, below. So it's going to be 7.8 minus 22.9. That's going to be a negative like 15.1 or so. There we go. The streptomycin effect is a negative 15.1. Now you can see 1, 2, 3, 4 antibiotic effects are shown to you. And let's show you the fifth one, because under estimates, you can expand that table out to not be just the first 4 leaving tetracycline unrevealed. But to be honest, frankly, you could take the first 4, add up those effects, subtract that from 0, or if you will, just change the sign to get the effect of the missing value tetracycline. But many people prefer the expanded estimates because it makes it quick and easy. Okay, so Brenna, that's the sum to 0 parameterization. I said that really sort of quickly today compared to yesterday, but it's something that you could probably do. As long as you know you have 1, 2, 3, 4, 5 means, you can take the average of those. Done. And then how far above the average of the averages is this group's mean? So 19.1 is how far above 22.9. Well, it's not above, it's below. How far below 22.9? Well, it's about 3.8 below. Indeed, that erythromycin right there has the effect of drop it down by almost 4 units. So sum to 0. I said it quickly. I said it yesterday. And Brenna, did I answer at least part of your question?
Yes. Thank you.
Yeah, this is one of those things where A, easy, B, sometimes you got to ask 2 or 3 times to get it down. But once you all get it down, this is pretty straightforward. And the nice thing is, once you get it, shoot, chapter 3 was like that. Anyone want to ask about this? I guess the indicator parameterization or the reference group style?
Can you just go over the interpretation of like the effects when you're doing it with the indicator parameterization?
Great question. So I first off want to say I want to choose which group to view as my reference group. And did any of you have a favorite antibiotic, or should I go with penicillin because that's got the name that corresponds to like the first one? I'm gonna go with penicillin.
Penicillin.
So yeah, you love penicillin, or
Big
it just
fan.
seems obvious. Big fan. Compared to the others, oh my gosh, it's so old. So what I want to do is to say I would like under column properties, I'd like to choose the value ordering. Okay, and you can see GMP by default gives you things that, well, in this case, it was in alphabetical order. You're going to get an order that's based on either alphabetical or perhaps what the previous user who created the data set left as his or her preference for the ordering. If I want penicillin to be in the last slot, that will allow it to be my reference group. I'm going to just move it down to the bottom, click OK, boom, done. I just reordered the values. Nope. Okay. So, so if penicillin was my reference, I'm going to compare each of the other groups to penicillin. And if you will, the intercept should be 28.6, but chloramphenicol, which has a binding percentage of 27.8, is 0.8 below the penicillin. So my chloramphenicol effect would be a negative 0.8. Let's go ahead and verify that if I were to do my analysis. Again, fit model, it's the way to go. And recall will be your friend. Let's just go ahead and start using it right away. Binding percentage by antibiotic. Let's run that analysis and zoom into just the things we care most about in terms of chapter 3, those parameter estimates. And so we have, the parameter estimates, but that's with a sum to zero parameterization. Under estimates, if you say, show me the indicator parameterization, if I've said streptomycin is my reference group, streptomycin should, the mean for streptomycin should be the intercept. In other words, that's the value you're going to tell me for mu. Mu happens to be something, it's the point of view that you're looking from. If we're standing here at a height of 28.6, who's above us? Well, only tetracycline is above us. Chloramphenicol is a little bit below us. And how far away from the reference are we? Well, the effect of chloramphenicol is to reduce the mean from the intercept mean, the penicillin mean, down 0.8 units. And that gets you to a 27.8 as an average for that group. I guess also tetracycline because it's an easy number and it was above the chloramphenicol average. If penicillin G average. So this is about a 2.4, math is failing me yet, 2.7 or so. Okay. If I took penicillin and say how far above penicillin's average is the tetracycline, that's, well, 2.775 units. The binding percentage for tetracycline is 2.775 above the reference group's binding percentage, penicillin G, that's a 28.6. So let's rephrase that. The effect of tetracycline on the binding percentage is to raise it from where? Well, from our reference group value of 28.6 to a 31.4. So Kendall, that I think was a quick walkthrough. Do you want to rephrase your question?
No, that was great.
Anyone else on that one? Okay, so that's the chapter 3 content. You had a video on it yesterday. You just watched this. There's even other stuff in past terms. And the lab from yesterday, I think, was something that most students grab onto very well, but for possibly one of the questions where it's like, what is the average of the averages? Literally mean, if we're talking about the flowers and dioecious trees, there's the male average number of flowers and the female average number of flowers. And what's the average of those two values? Literally, the average of the averages is what I say is going to be your intercept if you use the sum to zero style. One more thing, just because I thought of it just now, and I said it yesterday, but I didn't emphasize it as much yesterday as perhaps I could have. Whether it's the sum to zero parameterization style or the indicator reference group parameterization style, if the effects are all zeros, yeah, that means all the groups are the same. If the effects compared to the one group that's a reference group is always zero, it says all the groups are at the reference group. But if the effects of all of the groups are zero compared to the average of the averages, that means none of the groups is different than the average of the average across the groups. So they really do have the same style, but the interpretation of alpha, the effect of which group you're in, is just how far above the intercept are you? And the intercept has a variety of possible means. The two most convenient are your reference group and your average across all the groups. Here I'd probably go with a reference group. But if you didn't like that, the average of the binding percentages across the 5 antibiotics we are showing you here. Okay. That's 15 minutes talking about this example. Let's maybe move on. Any questions? And I'm gonna, because you all have things to do as well. I don't want to sort of like keep you hanging here. Do any of you want to talk about any of the questions from that sample exam? So I'm going to go through them one by one and expect that you'll stop me if you do say you want to talk about something from this first question. Here are a variety of possible methods that could be used to tackle some natural questions. 2 sample t-tests, 2 sample confidence interval. Well, the difference there is this is a yes or no question. This is like how much higher is the one group than the other. ANOVA, confidence interval for a slope, a prediction interval. We didn't really stress that this term. Hypothesis test for a slope, a confidence interval for an average value of y for a given x. The Shapiro-Wilk procedure, and something we haven't even talked about. So each of these is going to be one of the 9, and none of them that we've talked about or studied so far might be the answer that's like, oh, none of the above. So my claim is each of these, there is one best method of the 8, or it's not one of those 8. And in some cases, I'll even claim that there's 2 or perhaps even 3, depending on the questions that I ask of you, things that are reasonable to answer based on how you're thinking about the data. In all of those cases where I think, yeah, 2 or 3 reasonable answers, there's one that's best, full credit, other reasonable choices would get partial credit, but lower than best credit. I'm just talking way too much because none of you even asked about that. Hey, anyone want to talk about stem diameter and broccoli? Move past that. Okay, how about well, so how plants grow over time. So that would be an intercept and a slope, if you will. The intercept of the root length, okay, plotted against the days since the plant was transplanted. So I didn't actually probably show you the graph here, but the students looking at the test were staring at one. Anyone want to talk about that regression question? 3.
You're not going to have us draw a line through the graph, or will it be on the exam? Like you're
Okay,
not-
great question. On a test where I have people with a piece of paper in front of them, yeah, they could easily find a y value that goes with the regression line for 1x, and then find the y value that goes with that regression line for another x, and connect the dots and just keep drawing a straight line. It's much harder on a computer to do it. So not for you guys, but if it was a test on a piece of paper, seems quite reasonable. By the way, there's one student in one of my classes who sat in the far corner one day and had to deal with a question like this in the lab context. You know, create a scatter plot. And then I said, now add a line to your scatter plot. And rather than clicking the button that says fit line, the student literally held up a ruler and drew on the monitor. I was impressed. 1, 2, business major. 3, seemed to keep going to the bathroom a lot with his friends during the term, and they came back smelling different. Okay, so don't be that student. Don't draw on the computers. No, you won't have to do this. Okay. Another broccoli question 4. R squared, interpret that. Tell me, what way are these plants odd? Anyone want to talk about 4? Dead at day 78 out of 0 root length. In what statistical way would that plant be unusual? Certainly compared to the trend line as a whole, that would be a very unusual residual. Way below the trend line for that day, day 78. Some might even say that's an influential data point if that were a day 78, if that's an unusual day. An influential data point means it tends to tip the line one way or the other. I'm drifting on because I'm feeling bored myself, hearing myself talk, and I like to hear myself talk. And if I'm bored, there's a real problem here. Let's go into the Brown questions. Movedra, yes, that's how you pronounce it. Movedra. Okay, general linear model. Constant, that's an intercept, and then the effect of each of the different clones. On paper, if I don't tell you one of the clones impacts, could you find it from the other 3 estimated impacts? Heck yeah. Again, I'm bored. I'm talking to myself here. You want to ask about Brown 1? Ooh, Brown 2. I love this question.
How would you determine the impact?
Aha, which on question?
Yeah, for one you just
B.
read.
Yeah, literally the effect of clone 771 on bricks is to either raise or lower compared to the intercept, and the intercept is the average across the averages. Yeah, the average of the 1, 2, 3, 4 treatment averages. And so because that's the case, we're using the sum to 0 parameterization. The effect of it being a 23 and the effective being 115 plus the effect of it being 667 plus the unknown effect of it being 771. The sum of those 1, 2, 3, 4 effects has to equal 0. So let's take the sum of the first 3, change the sign. That gives us the estimated effect of it being in that last group. Happy?
Yeah, thanks.
Happiness is what we're aiming for. What about the second question? Brain weight and body weight. Okay, so here's one where, yes, I could make you a scatter plot and it shows brain weight and body weight are definitely related and you could predict the brain weight from the body weight, but the variability around the prediction trend line is quite different for different levels of body weight. Okay, and so let's just take a log of each the brain weight and the body weight, which causes our scatter plot to be such that a trend line of linearity still fits just fine, but the vertical spread around that trend line is about the same. The requirement of equality of spread works when we have log for each brain and body weight. Okay, so I guess some folks might say, if you're looking at brain and body weight themselves, we're not really assessing the relationship between those. But I would think, you know, if you're assessing the relationship between log of brain weight and log of body weight, I guess you are talking about a relationship between brain weight and body weight, yeah? Just because there's a log and maybe some exponentiation involved, we could work from the body weight towards the brain weight. And if it's a linear trend in log space, there will be an intercept in the slope, and the null hypothesis is always that the slope is 0 if we're looking to see if there's a relationship or not. Test statistic most commonly used. Aha! That would be the t-test for the slope. Take the estimated slope, divide through by the standard error, get that t ratio, if you will. In this case, it would be highly statistically significant. Actually, the t ratio happens to be the square root, in this case, of 697, and it will have a p-value of exactly less than 0.001, like we do here in the ANOVA table. Okay, moving on, because none of you asked other questions about our animals, brain weights and body weights across the species. Okay, ANOVA question, fill in the blanks. Anyone want to talk about that? I'm not feeling it. Okay, you're not saying anything. Okay, ooh, true or false is a great question. And explain is always nice. So for you all, I might very well have some of the questions on Canvas be identify true or false. Yeah. And then the second part, or if you will, the next question could actually read as, please explain your answer for your choice above. And those all read carefully. And yeah, some of the points will be T or F. Did you get the right answer? But the explanation is also quite valuable for me to assess your level of understanding. Because if you wrote T for true, and then you write down something which actually doesn't convince me that your answer should have been true, yeah, I have to sort of grade you accordingly. And so maybe you just guessed there. Or if you answer false, and you, in fact, the true answer is true, the correct answer is true, but you answered false, your explanation might make me think, well, okay, you had this thing slightly wrong, which is why you answered false, but those other thoughts are good. So I could give a pretty good partial credit to someone who maybe even answered the true or false incorrectly. Let me give you my answers on true or false. Can we do t-test things with an ANOVA? Yes. Can you do ANOVA things with the t-test? No, unless there are only two groups. If I have a t-test, could I use regression to do that? Well, I guess so. An intercept could correspond to one group's mean. And if we use that reference group parameterization, the other group would have an estimated effect. And that estimated effect will have a t-statistic that tells us whether it's statistically significant or not. Yeah. So in the context of regression, we can embed a t-test. In that same sense, if I had a regression problem, could I handle it by an ANOVA? I would answer this one as false, but you'll notice that there's always an ANOVA table presented with regression output. That is, however, the ANOVA that corresponds to the regression, and it's a little bit different than the ANOVA in the classic compare multiple groups context. So someone who answers incorrectly on D, but gives me an explanation for why they provided the answer that I consider wrong, they're probably going to get pretty good partial credit, because I'm going to know, oh, that's what you were thinking. And yeah, that makes sense, even if technically wrong. Some folks would say, if you're careful enough, all of the questions this term could be handled via the method called regression or the general linear model. Okay, another question? Okay, moving. How about pregnancy and vegetarianism? P-value of 0.982, you're thinking, well, no, across my groups, it really don't matter. What about the family income based on the father's years of schooling? Does it look as though there is a relationship? Yes. What sort of an analysis is this? It's got to be a regression line, because we've got an intercept and a slope given. Anyone want to talk about this funny blue question 3? Okay, so that's it. I'm going to say, based on the nature of the questions today, we had a quality 10 minutes of content and sitting around for the rest of the time. And I apologize that y'all didn't have more questions, but again, really, that's not on me. Oh, Diana.
I actually did have a question on this one.
Yeah, good.
I think it was C. I was looking at the answer, and there was an answer with using the confidence interval, or where you just subtract it. And I was wondering how that would be graded if you had subtracted it instead of used the confidence interval.
Well, okay. So if you look at the intercept and slope, right? You could tell me the average income where from a family where dad had 16 years of school versus where dad has 12 years of school. So you can tell me 2 y-hats. And your answer will be, the difference of those two will be 4 times the slope. Because again, what is the slope? The slope is the impact on y of a 1 unit increase in x. And if we go from 12 to 16 years of schooling, that's like 12 to 13, 15 to 14, 14 to 15. That's 4 separate 7.09 increases. So the answer is going to be like 28.36. So you could do that, which is great. But I'll tell you, if you have the confidence interval, you're not just estimating that number, which is 4 times the slope. You could also tell me how far off your estimate is likely to be from the actual truth. An estimate by itself is sort of naked. if you can produce a confidence interval for not too much more effort, I'd say do it.
Okay, yeah, I was just wondering because of the wording where it said how much more on average. I wasn't sure if that included the margin of error.
It doesn't specifically say, please add a margin of error. And I think the way I graded this question, that term was out of 5 possible points. The folks that answered it with the confidence interval got 5 out of 5. And the people who simply answered it correctly without the margin of error, I think I gave them 4 out of 5. Because what they did was really good. It just didn't do everything that one could have easily done. But that was a question written for a term where students, when working on the test, if they wanted me to rephrase the problem, they could come up and ask me to rephrase it. That's a little bit harder via Zoom and Canvas. And so most of them didn't ask, and most of them did produce confidence interval as their answer. But those who weren't sure asked, and then they for sure gave the confidence interval answer. Okay, so I would suggest the following. Look at the answers to these questions. They're already online. You probably already have. Second, if you're not sure about something, I betcha someone in one of those other 2 videotaped sessions that match up to going over the answers to these sample exam questions probably did. And you might be able to tell from the videotape, like you can, like YouTube, you sort of scrub it forward or backwards. You can advance until you see about the question you're interested in, then go back like, a minute or 3, and you can probably spot a discussion of the matter you'd like to address exactly. Or there is always email. I'm going to be not so available tomorrow between 1 p.m. and about midnight, but at several points in time, I should have access to my email via a phone. And so if you do send me a question, please do it before you take the test, 1. And 2, send me a question in such a way that I can answer as quickly and briefly as possible without spending a lot of time typing, okay? So if you send me in the context of your question enough that allows me to say yes or no, 5.7, that's going to be great because I'll be able to get you your answer sooner. One other thing before your question, Alexander, and that is, am I forgetting it now? Oh yeah. If something happens during the course of the exam, and there will always be someone who has their computer freeze up or the internet goes down or something like that, just record it to the best of your ability, document it by like taking a picture if you need to, and just email me and let me know what happened. And I can always adjust the test, perhaps by reopening it and giving you an extra 4 hours or perhaps even an extra full day. There are ways to make sure that if bad stuff happens technologically, we can solve the problem. Just be clear, let me know sooner rather than later, and I'll do my best to find the real problem and get it fixed for you. Alexandra?
Hi, could you hear me?
Now I can.
So I'm still a little confused on the format of the exam itself. Would it be like a quiz on Canvas? Would it be on a PDF? And how would you like us to answer the questions?
Okay.
Like on a doc or on a piece of paper?
Yeah, great question. It's going to be like a Canvas quiz where some of the questions will be multiple choice. Some will be maybe you type in a number and then I'll grade you based on how well you tell me the number that's right. Some of the questions will be, hey, type in an answer that you like here. And you'll go ahead and start typing away and you'll be happy with what you type, or you might say, you know what, this would be a lot easier to write down. And so maybe you'll type, here's my quick answer, but please see the extra attached piece of paper where it says question 12. for additional content, and then you'll go down right on the piece of paper, something
Okay.
like F equals, and then you'll discuss something with pen and paper. And if that's a style that you like, you could use it all over the place. Just be sure you upload that pen and paper sort of stuff. Take a picture, scan it, upload it with the test. I think I gave y'all 5 minutes extra to do the test. So you should be able to take those 5 minutes to upload your handwritten stuff, and you could write on any piece of paper you want. And as just make sure you upload all of the pieces of paper. Does that get your question, Alexander?
Yes, that answers it perfectly. Thank you.
Cool.
Where does this paper get uploaded? Is there
In
a
Canvas?
is there a specific assignment it's under, or
Well, the assignment will be called Exam 1 or something like that. And when you say click your way into it, then I think you have to indicate, yes, I want to start it now. And then you start working away at the test. The last question is, hey, do you want to upload anything? Please go ahead and drag that file into the upload this section, something like that, like the typical Canvas uploads, like with the lab activities.
okay, thank you.
And another follow-up, Alexandra?
Oh, sorry, I just forgot to lower my hand.
Yes, vestigial hand. That will happen sometimes. Okay, we got 3 minutes to go, but like I said, I'm done. But you might have questions, and so that's fine. I'll hang out for a little bit, but I'm just going to call it a day and stop the share and stop the recording. So that way I can upload this sooner rather than later. Usually takes an hour to an hour and a half for the recordings to process and get to me for me to upload. So look in no earlier than about an hour for this. If you want to watch this whole thing again, which makes me question your judgment.